Alaikum, ladies and gentlemen, welcome back to another live stream. Okay, let me share the link real quick. Please join my Discord server so you can get notified of new streams. All right. Okay. I think we're live. Can you talk so I can make sure your audio is in?
Yeah.
Okay, cool.
Can you hear me?
Yeah, it works. All right, so can you check the stream real quick, make sure it's fine?
Yeah, I think I can see it. Yeah.
Devrisco, welcome to live stream. How's it going, man? How's it going? What's up? Hello, Andrew. Oh, I think that's you.
It's me.
Okay, can you please introduce yourself?
Yeah, I'm Andrew. I'm a third year computer science student. Yeah, I like writing C, and now we're gonna learn Zig.
That's great. Okay, so we're gonna be teaching Zig to our friend today, and let's go. If you guys want more Zig teaching content, just like this video so I can know to make more of it. Other than that, let's get started. So we're using live share extension with Andrew right here. And can you see my terminal? I think I need to share it with you, or I think it's already shared, but it's read only. Okay,
I think it's yeah.
Share terminal, read write. Okay, cool.
Yeah, I can
do you
see
have the Zig Analyzer extension? Okay, Zig. Just search for Zig language. It's not the best LSP in the world, but it should work for now.
I think I have
Zig
it.
language, yeah. Okay. Yeah. Other than that, can you see my terminal? Right.
I think yeah.
So make a new folder here, and call it whatever you want. Today I'm gonna try to teach him by projects instead of what I've done before with other people, which is I teach them one feature after the other. Today so basically Andrew have fiddled with some AI stuff, some neural networks from scratch, and I'd like to actually learn that. So today maybe I'm gonna learn something too. I'm not gonna be only teaching. So he's gonna try to make a simple neural network, I think, or something similar to that, and I'm just gonna be guiding him through the Zig language basically. So okay, mkdir, and just call your project whichever you want. Yeah.
Okay. Zig. Oh, that's I guess.
Okay, go inside of it.
That worked. Okay.
Great. Okay, so Zig init. Clear, yeah, sure. Zig init.
Okay.
Great. Okay, I'm gonna enter into that directory in VS Code here real quick. Where is that? Zig. Okay, cool. Select folder. Did it?
Oh.
Yeah, I did.
Let's
see. I'm gonna give you the link again. So.
Okay.
All right. Here's the link. So yeah, here's the library that he's made, by the way. He's sent me this. He's still working on it pretty much. It's called Teeny's Grad. He made it in C. And it's actually a lot of cool stuff. The title, by the way, is not really C-noob, it's just a little bit clickbaity. It's actually not that bad at all. At least looking at the code right here. Yeah, there is some cool stuff right here. Other than that, let's
think
get going, I guess. Yeah?
I think the link is broken there. I accidentally clicked it and now it's like broken. Can you resend it just really quick?
Oh, I see. Okay. Let me try. Copy again. It's the same link, actually.
Yeah.
Try again.
Okay,
you're joined.
Yes.
Great.
Okay.
So let me show you
Cool.
my terminal too. Read write. Okay, have you opened the Zig project before?
No, I have no idea what this is.
The title is called Hello Robert, welcome to the live stream. How's it going? I remembered your name right now. Okay, cool. So we have a main.zig file and we have a root.zig. Okay. And then a build.zig file. Okay, so we're gonna go straight into work, I think, here. So yeah, what the first thing that you want to do in your project right now? So where should we start with the project? And I'm gonna tell you to help you with the Zig. So you kind of like write C code, or tell me what you're gonna write. Like, let's say you're gonna make a struct, for example.
Yeah. So if we make a struct called Tensor, and that'll basically just be like a pointer to a buffer basically with all the data in it.
So you want to allocate it. Can't you do it statically, maybe?
Yeah.
Or is that not enough?
It's gonna, well, like you'll want a bunch of tensors, and they might all have different like sizes.
Yeah, they may be big, right?
Like,
huge data.
yeah.
Okay, sure. Let's go ahead and
they'll be like, they have a bunch of different, like, yeah.
Sure. So try to just do it like you would do it in C, or.
Okay. Okay. Something like this, and then.
And what's the fields?
We also need like a size. Keeping the size of the buffer. I'm reading the code that I've written in the repo.
Sure.
So we need like I just want to keep it basic for now because I don't know.
Yeah, sure. We can start simple.
Okay, so
a tensor. Like, what is a tensor, real quick?
So it's just like an n-dimensional array.
Okay.
Do you know what I mean?
Like, I guess you can do math operations on it.
Yeah. So you can add like.
So what's the difference between a tensor and vector?
A vector is just a one-dimensional array.
Okay.
And a matrix is a two-dimensional array. A tensor is all of those. It's like one-dimensional, two-dimensional, three-dimensional.
It can be in it. So basically, a generic vector, I guess.
Yeah.
Or a generic matrix, actually. So like dimensions, not. Yeah. Okay. So you can write right now here const tensor with the big T, that's the naming conventions, I think, for types, equal to a struct.
A type of struct.
Yeah. You open the, just like you would do in C, right? And here you write your fields. So let's start with buffer. So type in buffer and then a colon. And so that would be a slice, because a float pointer with a size is just a slice. So you would say brackets, 2 brackets, yeah, exactly. And then here the type of that T value, which is in this case, what is it gonna be? It's gonna be generic, right? It's gonna be generic.
Yeah, we can make it generic.
But let's start with a concrete type like, I don't know, F64 or something, and then we can make a generic later on.
Okay.
So start simple. Not there, here. After the, here.
Oh, after it. Okay.
Exactly.
Like that?
Comma, yeah.
Oh, okay.
And then a comma there, and the semicolon here. And then
Okay.
This is basically this two right here. So a slice is just like a wide pointer. It contains a point, you know, a pointer like this, and it also contains the size. So where to start and how much. But of course it doesn't own the data, just like a pointer, but you got the point. Anyways, what else? Is there anything else? I think that's it, maybe?
Yeah, we could just start off with that.
Okay, cool. Now, what do you notice here with the difference? What is the difference that you notice between a C struct and a Zig struct, like this?
I guess the biggest difference is you're declaring it as a const tensor and then assigning that to this, maybe, instead of like making this type.
All right, so you notice that in Zig, right, the syntax is consistent, and they just reuse syntax instead of creating new syntax for no reason, right? So you just say const, right, tensor is equal to an anonymous struct. That's simple as that. And then a buffer, and after it, the type. And of course, we have a slice in the compiler. It's not just, you know, a size and a float pointer, right? So, okay, great. Now let's make this generic. Now, generics in Zig is quite interesting. It's honestly my favorite when it comes to not my favorite when it comes to, but templates and metaprogramming in general. So here's how you do generic. So make a function fn tensor, call it tensor, just like your struct, yeah.
Okay.
And you know, just like you would do in C, just open the, and then then the body, right? Open the, great,
like
yeah. And here the return type, so it's gonna be in this case anonymous struct, so we don't know the type yet. We're just gonna say some type. Just say type here, not here, right? Where my cursor is, exactly. So we're gonna return a type from this tensor. Now in Zig, types are first-class citizens. A type is also a type. It's that simple. So like it's not like other languages where you have to make, you know, special considerations for a type or compile time stuff. Like you would have to do templates and such things. No, in Zig, you want a type, you pass it as an argument, or you return it from a function. It's that simple. But of course, they have to be in compile time, right? Okay, so fn tensor, and here we're gonna return this struct. Just copy it over, I think. Return. There you go. Control S, cool. Now here, you would, so basically we want to make this generic, right? So we could just pass in the type here, some type t as an argument. So t, or we could call it scalar with a big S since it's a type. Or honestly, no, just, I mean, yeah, go ahead. T, let's just call it scalar, I think, right? Type, yeah, it is a type, good. And now, instead of F64, you just give it the type. There you go. Redeclaration, yeah, now you can remove this.
Is type of, so type is of type?
Yeah,
type.
Exactly, a type is a type.
Okay.
So that's, welcome to metaprogramming, basically.
Yeah.
So you can remove this right now, great. Now, how would you instantiate this type? Because this function helps you make types, right? It's a factory of types, kinda, right? So let's say you want to make a tensor of F64s. So say const tensor with a big T, yeah. F64 after it, maybe. And equals to, and then you would call this function to instantiate a new type. And the scalar would be, yeah, exactly. There you go. It's that
Okay.
simple.
Cool.
Isn't that so
That's very
powerful?
cool. Okay. Yeah. Okay.
Isn't scalar supposed to have comp time in front of it since it's type 1.ws? Welcome to the live stream. Yes, I just forgot. Please add comp time here before the scalar, because this argument is supposed to be passed at compile time. So just type in comp time there before. There. Exactly. There you go. Okay, so now let's make the main function, because we haven't done that yet. If in main, just like you have create this function, right? Main, exactly. Yeah. And then the type, yeah, just open the thing, right? The type would be void.
Okay.
Okay, cool. And now return 0, I think. Or actually, no, we don't return anything because it's void, right?
Okay.
So, yeah, Control S and run this, Zig build run. Let's make sure it's compiles at least. Okay, what did I miss? Main is not, oh yeah, it should be public because the linker have to find it, have to be able to find it, so pub. There you go, Control S and run again. You can notice that I haven't programmed in Zig for quite some time now. There you go, you got your first program working. But yeah, cool. Okay, can you make a tensor right now? What do you think it would be like? Just like you've done before, const. Now you're gonna create a tensor instance, basically. Yeah. Const A, maybe. I don't know. A yeah. Equals to
64.
Sure.
Be like that, or?
Yeah, sure. Go ahead. Go ahead. Okay. And you would open these guys right here. Yeah. And now okay. dot, and the name of the field. And buffer.
Like that?
Yeah, buffer is equal to. And here you need the slice. But this is not an owned memory. You need the memory to exist first of all, because a slice just refers to an already existing memory. So here you can do we want to, okay, let's allocate some memory, or yeah. So come here and say, so we need the allocator. In Zig we don't have an implicit allocator. You pass all your allocators, so any function that needs to allocate, you pass it an allocator, right? So there's no global allocator basically, it's all explicit, right? So const GPA, or general purpose allocator, is equal to std, I don't even remember what namespace it is. Let's look for the Zig std docs. Okay, general purpose allocator. Yeah, it's in std.heap.general purpose allocator .heap. Yeah, namespaces, as you notice, you know, you just, so like every file in Zig is just a struct. Okay. So namespaces are also just structs. Okay. Yeah. Okay, cool. Very simple. Okay. So now here you would say dot to infer the type of what the general purpose allocator takes. So basically, instead of saying std.heap.generalpurposeallocator.config, you would just say dot to infer it, just like Rust. So, and now you open the, hello heads, welcome back to the live stream. How's it going, man? Okay, open up the thing here. What is it even called? Brackets, or not really? Crap, I forgot the name. Yeah, just see what I'm what I'm highlighting right now. This. Here. Okay, I can just do it. Yeah. The curly braces. Yeah, exactly. All right, great. The thing is, this general purpose allocator function returns for you a type, right? So you need to instantiate that type. So you instantiate like this. It's kind of like C++.
Okay.
Expected expression found. Can you run this? Oh crap! I forgot. Hold on. We need the other stuff. Yeah. So after that, we're gonna get an allocator. So you say const allocator. No, not there. Where exactly? Allocator is equal to GPA.allocator, I think, if I'm not mistaken. There you go. So what this returns, basically returns a vtable from that general purpose allocator. You know what vtable is?
Yeah. I've heard of it.
So basically the way inheritance is done in C. And in fact, even in C++, but in C++ you do it using interface and, just syntax sugar, right?
Okay.
So because we have a lot of types of allocators, so this is basically dynamic dispatch. We take a vtable. If you control and click on that symbol, you're gonna look into that and you're gonna see that it returns a struct called allocator, which is the standard memory allocation interface, right? So it contains a pointer to self and a vtable and a vtable is basically a struct of function pointers. And it would basically, when you're gonna call functions on it, it would just take self and feed it into those function pointers, right? Alloc, resize, and free of that particular allocator. And this is how you do dynamic dispatch in Zig. No, sugar, no, what is it called? No magic, basically. Everything is in front of you. Okay, so we need to allocate some memory. Isn't it var allocator not constant because you want to see allocator not constant cd? Yeah, I'm gonna see about that. So what I do and how I program in Zig, I would just always start with constant until the compiler actually complains to tell me that it needs to be var. Then I do it, just to make sure I'm not making anything var that shouldn't be var or doesn't have to be var, right? Okay, so let's use this allocator to allocate memory. Allocator dot. What's the functions that you have there?
The functions that we have are like aligned, alloc, create, destroy.
Okay, so we need alloc because that one you could give it the comp time t type of the slice that you want, and the n, how much elements in there. So you can allocate an array essentially. Exactly. Comp t type. What is the type? Great. And the n usize?
We just
just pick an arbitrary, comma, comma here and the semicolon here.
Okay.
Now let's try to actually print this a first of all. So come here and say std.debug.print. Great. So great that you use the tab, so it gives you the thing directly. I don't have to even tell you. So what is the first argument? The format.
It's
right.
It's like a array of bytes.
It's a slice. It's a slice of U8s. So in Zig we don't have special strings. We just have a array of bytes. Selim. Selim brother, what do you think about including allocator in a struct? Wouldn't it be more memory efficient to use some kind of context? Like J. I don't know J, just saw it once. I don't have that. I haven't looked deep into J honestly, because I don't want to send an email just to try language. But I've seen a bit about context stuff. I don't know how to feel about that honestly. It's kind of interesting because it's kind of like, what is it called? It's kind of dull to pass an allocator every time you want a function to allocate something, but at the same time it's kind of, I love it because you can see every function when it's gonna allocate something. and you give it exact. So like there's no implicit stuff, right? It's all explicit in front of you. Here's a function, but this function will allocate, so give me an allocator. So very explicit, very straight to the point. Can't you already do that in Zig? I'm not aware of that. Like, but I don't think. Do you know context in J? But I think it's basically, if I understand it well, you kind of like you can. I think in a scope or in a function or whichever, I don't know. But basically in some certain context, you can set a default allocator in some sense, I think. So kind of like other languages where they have a global allocator, but it's more explicit than that, but less explicit than the Zig way. So it's kind of like midway between the two. At least that's what I understand, but I didn't try J, honestly. So either way, so we have count time format, which is a slice of const u8, so bytes, right? Okay, so just make a string, a literal string here.
Just like anything like.
No, yeah, sure, fine. I mean, okay, and do a colon maybe, and then you can say to a placeholder, just like in Rust, if you know Rust placeholders in format. Here, first of all, you need a placeholder.
Okay. Is that exactly like Rust or?
Yeah, kind of like Rust, yeah. And here the arguments. Now here you need a tuple. There's no variadic arguments in Zig. If you want variadic arguments, use a tuple, which you do using a dot, and then you open, what is it? Curly braces. You open the curly brace, right? And then you give your arguments there, which is in this case your tensor A.
Okay.
And semicolon, right?
Just like that?
Yep.
Okay.
Try that. Okay, what is I failed expect? What? Hold on. Oh yeah, alloc actually returns. Yeah, notice in the alloc function, what does it return? The type that it returns.
Allocator.
No, I mean alloc function. The alloc function.
Oh, sorry.
Hover over it. See what's the signature.
Returns an error.
Exclamation mark, right? And
yeah. A slice of type
T. Yeah, exactly. So that's exclamation mark is basically a union. So that basically means a union of error and T slice.
Okay.
So kind of like either error or a T slice, basically. So that's kind of like the result in Rust.
Yeah.
So you need some way to unwrap it, like in Rust. So you would do. Freak, I don't even remember how you do that in Zig. How do you guys do it? I forgot. Man. Is it... bruh. Oh, try, my bad. And welcome, Jonathan Marlon. Welcome back. Yeah, try. Try here.
Okay.
Cool. Let's try that. Control S and run it. What did we miss again? Expression. Try allocator. Oh, by the way, I need here, but hold on. Why it's saying that? Hold on. Tip for Zig, you can define format function or structure print with the cd.debug.print. Interesting. I don't know why it's complaining there. Maybe I'm missing something. But either way,
I didn't say that.
Make it just like a union. So it would basically be a result. So you can use the try function. Because basically the try function would return the error from this main function if it found one.
Okay.
And try again. I'm not sure why it's complaining there exactly. Maybe I'm... okay, great. So now we have another error. Great. So here cast discards const qualifier. Where? In GPA dot allocator. So the GPA should be variable. That's what it's saying. Okay. Control S and run. And what you got there?
Random values. Just a bunch of random values.
Yeah, exactly. Just some garbage values. I think they're probably at the defined values, so you can catch it at debug time, maybe? I'm not sure. But anyways, so... Okay, so what we should... Well, let's actually do some cleaning up, I guess. Let's make an init function. So how are we going to do that? We're going to put it here inside of the struct. So you make an init function.
Okay.
fn init, right? So the struct here is basically the namespace itself. So you open the... Just like a function, yeah, just make a right? And what you would... Like, what it would return, first of all. What it would return. It's basically kind of like new, right? It would return the type. This struct, right?
Yes.
But the problem that we have here is this: does this struct have a name?
No, it doesn't. It's anonymous.
It's an anonymous, right? So we do have a built-in function called this that would allow you to get the current type, that like the type that you are in currently. So you could say this, right?
Okay. Whoops. Like that?
Yeah, exactly. You would call it. It's a function.
Okay.
There you go.
Okay.
It's a comp-time function. Okay. And now what you would need to initialize this tensor in terms of arguments?
Let me see, actually.
Well, try first of all to make it maybe the body of the function, and it's like it would return this, just like you initialized here.
Okay.
Okay, so what you need there to initialize this?
You need an allocator.
Let's go. Gotcha. So we need to pass in an allocator here.
Okay. I don't know how to do this now.
No, just try allocator and colon. Call it allocator.
Okay.
Colon and scd.mem.allocator. That's the vtable struct, yeah. That's the interface. Okay, cool, comma. And what you need more than that?
We have, but isn't this, so, is this not supposed to return like a generic tensor? Or
yeah, it is.
We need like yeah.
So what we should do here, what we should replace this with, we need the type of the struct that we're in right now.
Yeah, so would we pass with the type in init?
How did we get the type here? This, right? So you could just use it there. Copy,
Where do you want me to use it?
Yeah, try. There's a better way, but try that first. Copy it, right? And paste it here.
Is in the function
here. Instead of that type.
Okay. Wait, I'm confused now.
Yeah, you have to call this to get the type right there. So just like this. Let's see, hold on. Like that. Oops, what I've done. Like this, right?
Oh, okay.
But this, yeah, this is a built-in. Yeah, this is a built-in function, so it starts. It's built into the compiler, so it starts with this symbol right here. But Zig can actually infer the type, so you could just say dot instead.
Okay.
And though you would need to return this, it doesn't return it implicitly like Rust. Return.
Okay. And
Tunify basic, where are you from? And I feel like you're an Arabian. I'm Moroccan, pretty much. Return, yeah, great. Try allocated. Okay, what is this? The type there? It's what it should be.
It should just be.
What's the general type that we have?
just type?
Yeah, scalar.
Or
Exactly.
scalar?
Exactly.
Yeah.
Welcome to Nify. Welcome, my Tunisian brother. Let's go. Okay, so instead of 10, you
That
would
should probably be
have the count,
a
right?
parameter.
Initialized.
Yeah.
Exactly.
How do you int?
U size,
Like,
because it's, you know,
okay.
it's like size t.
Yeah.
Okay. But we have a little problem here, though. This try here, what it requires. Because it can fail, and then when it fails, yeah, there you go.
So is it like that?
Great,
Okay.
yeah, perfect. And notice here, if, as I said before, you actually are supposed to give it the error type here, but if you leave it like this, it would just infer it, basically. You see?
Okay.
So in this case, we only have one error, so we may be able to possibly use that. Where is this? It's in scd.mem.allocator.error, maybe? Let me see. Just so, let's see, error. So yeah, you could do this. Otherwise, it would just do it for you, right? It would just infer it. You see? Because right here, we only have one type. Otherwise, we can have, if we have multiple errors, we actually have another syntax that I don't even remember. But yeah. Okay, so that's great. Now use init function instead right here.
So what I do, it's a function. So what I do, like,
Yeah. Init.
and then
Exactly.
like that.
But init, what it returns?
Oh, you have to try it, do you?
Yeah, exactly. And try this out. And there you go.
There we go.
Same thing,
Right, cool.
but a little bit better. That's basically the convention to call it init, right? But it's not really required. You can call it whichever you want, doesn't matter.
Yeah, I guess so.
Okay, cool. So, and by the way, you notice that this is kind of like just alias, basically.
Yeah.
You see?
Okay, I guess. Yeah.
But like, you can't call this. You can call this multiple times. It doesn't matter, since compile time functions are memoized, meaning the returns, you know, gets computed only once. When you call the function again, it would give you the same output, right? It would give you the cached output, right? So, but yeah, but it's nice to make some readable code, right?
Okay, so calling this would be the same as just doing this.
Exactly, yeah. It's pretty much the same.
Okay.
Nice. Cool. Now commute the zeros to zeta function. Forgot to say the same output as last time. Yeah. Okay, great. So what we should do next for our tensor? What we need next for it? Well, we're initializing it, right?
Yeah.
Don't we need something else?
You need like.
Yeah.
Some sort of struct, like freeing it.
Exactly. So fn dinit. Whenever you create something, you have to destroy it. So there you go.
Okay.
And here you would get self. There you go.
Okay.
And
now
I don't think you need that in Zig, or is it? I don't think you need that. Anyways, go here, void, and open the thing, right? Void return type. Missing parameter name or type. No, I think you do need the argument type, maybe. So we could say this. Yeah, okay. And then what we need to do here, in your opinion?
We need to like deallocate the buffer.
Right.
And that's pretty much it, I think.
Okay, so how are we gonna deallocate it? So we need the allocator.
Yeah.
The same allocator, right? There you go.
Yeah.
Yeah.
Okay. And
Then you would use the allocator, yeah. Dot.
destroy probably.
Not destroy. Destroy, the counterpart of destroy is create, which is used to create one item, to allocate one item.
Okay.
But alloc and free is used for multiple items in an array, right? So free,
okay.
exactly. And there
And then,
you would pass in what? Self dot.
Buffer.
Exactly.
Like that.
Semicolon, yeah. And yeah, that doesn't return anything, so that's great. So try to call that now. Okay, run this.
Okay. Could return an error, shouldn't it? Yeah.
In use
calling
function param. Hold on, no, keep it. I think I'm missing something myself here. How do you do self again in Zig? Zig documentation. Language reference. I think they're called generic data structures, yeah. And how do you do this? Let's see. Self. Oh, my bad. So here you need to give it a pointer because, yeah, I think so. Try this. Make it a pointer here.
Which one?
Exactly. Try that.
Okay.
That works.
Does that work? Is that an error?
Hold on. Clear, and build run. No field or member function named init. What? Yeah, I'm not worrying about defer right now, but like, where's the problem? Oh, hold on. What? Where is this coming from? Tensor. Oh, you're not using the function, right?
Yeah. I forgot to put that back in. Yeah.
Okay, save and run. Did you save? I don't think you saved.
No, I didn't know.
Expected type found. Const. Yeah, so this basically means that you need to make this variable now. Okay, try. And you have a little problem here. What is it? Try to guess what is the problem.
We're free.
What's you got? What is the error? Segmentation fault, right?
Yeah.
Why?
I'm trying to access freed memory.
Exactly. So there you go. Okay, try now.
Save.
Yeah. My brain crashed when you didn't save and run it again. Like, what?
Yeah.
Okay, so...
Okay. There we go.
Now, the problem with this, you can easily forget this. So, like, you would have... That's the first thing, right? So, you can have a lot of code right here, and then you have to D in it, right? So, that's... sucks. So, but thankfully, Zig is sane enough to give us the first statement. So, we could do this. And this would run after the block ends. And this doesn't save us just the fact that we don't have to, have multiple lines. That's one thing. The other thing is the fact that not a lot of people do the allocation and allocations correctly in C. So what would happen, like, they would do some other operation after the allocation, right? I don't know, they would allocate, let's say, something else, right? Var B, and try tensor, right? And then this B would actually fail, let's say, right? And so what happens, this init function wouldn't run. So we have leaked memory. Congrats. You see? Without the defer. I'm talking without the defer right here. You see what I mean?
Okay.
So if this fails, and let's say you have, remember to, well, I mean, yeah, basically, you're gonna leak both, right? You're gonna leak both because you're gonna go out of this function. You're done with it, right? And you're just gonna leak these memories.
Yeah.
But if you do this, defer right after the init, and then same thing here, defer b.dinit. Now, this defer function would make sure if this try or anything made it so that you go out of this function, this defer would actually run. And they would actually run in the reverse order, right? So here we have defer a.dinit and b.dinit would actually run first, right? And then a.dinit, right? So just like how you do it in C manually, which is really, really suck. I don't know why in 2024 we don't have a defer statement in C and C++. It's wild. C++ there's RAI, but it suck. It's like very painful to work with. But, well, you got the point. Anyways, it's as simple as this. And you can see that in Zig, we basically prefer to be explicit, and we don't have a lot of magic going on. Everything is clear. You're instantiating a new struct, you're initializing it, and that initialization needs an allocator, and so on. You see? No magic going on. Without defer, the memory management is completed with the text representation of code. Okay. So, great. Do you understand right now? What do you think about this? This is
that's pretty cool. I like the defer statement.
Yeah, that's my favorite. Well, not my favorite. One of my favorite features about Zig is defer.
Yeah, I've seen it in Go.
Like if C just had this single statement alone, it would make my life way easier in C.
Yeah.
There you go. Okay, so what we need next right now for Tensor struct? What should we do?
I think.
Well, one thing, by the way, one thing. Here, notice in the init function, we're passing an allocator and init allocator. What if we passed another allocator here?
Oh.
Let's say, let's try to create another kind of allocator, okay? So say var arena, because we have arena allocators in Zig too. Var arena.
Okay. What's the difference between an arena again? I forget what an arena does.
Yeah, I'm gonna explain that in a second. Just make an arena right now.
Okay.
Var arena, yeah. Complete. No, not that.
Yeah, I know. Arena.
Okay, equals to.
Is it heap?
I'm not sure where. Yeah, there you go. And what that return requires, right? T type, right? The allocator takes an existing allocator reps it. Oh, it actually takes. I think it takes an allocator itself. Let me see if it talks about this here. Yeah. So yeah, it takes its own allocator. Honestly, you see, let's just use the allocator of C, okay? Instead of arena allocator, let's just use the C allocator. So var C allocator, I guess, or whatever, is equal to. Where is it? std.heap.page allocator. Or actually, that's the page. No, that's the page allocator. I'm pretty sure there is a C. Hold on, std.c, I think. Is it like? Yeah, I think that's basically it. cd.heap.cl. Sorry. Anyways, let's see if this works. Okay, try this.
Yeah.
What is the error? Oh, we cannot use it. You know why? Because Zig applications by default aren't dynamically linked, they're statically linked. Meaning that they they're independent of the libc,
Okay.
right?
Yeah.
Which is a very rare thing. I've never seen a language give you static applications. Like usually applications would always link to libc. So if you want to link to libc, you would go to build.zig, right? You see build.zig?
Okay.
So
Yeah.
this build function. So the build system in Zig is kind of like a graph. So these functions that you see, like add static library, install artifact, and stuff like that, these aren't ran like immediately. They're actually, you know, built in a graph. You see?
Okay. I get you.
Yeah, they're building a graph, and after this whole thing is done, that graph gets ran, right? Depending on Zig, right? So let's just say, I'm not sure I remember, maybe link static, link.
Where is it?
How do you link the C library? Oh, I think it's called right now link system library. I think they changed it. They constantly change this build system. Oh my god. I think it's exe. Hold on, where is it? Exe. Where is exe here? There you go. Okay, cool. exe.link. Link libc. Right now it's called link libc. Okay. So you see where I'm typing?
Yeah, I see it.
Link exe. It doesn't matter where you put it actually, just as long as you can reference the exe, right? So this is a graph. Order doesn't really matter that much, right? So try now.
Yeah.
We're linking libc right now. What happened?
Is it wrong? Kind of hanging.
Yeah, it's hanging weird. I mean, I'm expecting it to go wrong, but I expected an error or something. But
Oh, did it run there?
what if we give it the C allocator in both? What is happening here? No, I think we have done something wrong. Hold on. Did they change something with the build system again?
Again?
I hate the build system right now. Keeps on changing. Okay, and if I link libc, or maybe it's just compiling libc for the first time. Maybe it's doing that for the first time. So that's why it took that long, maybe? Because like Zig have a caching system for the build, so you don't need a make file. It's like,
Yeah.
you know, just Zig build this, Zig build that, Zig compile this, Zig compile that, and it just does the caching for you. Like, you don't have to. But what the heck is going on here? I'm not sure what the heck. But I think right now it works, maybe?
Okay.
Okay, I think right now it works. I'm not sure why it have hanged right there. But anyways, what we got, what's the error right there?
The current error we have.
Go up, go, well, hold on, let me, I know there's a bug with the terminal in live share, so clear and build yourself to make sure the terminal is in consistent state for you. Okay, go to the start and read what you got there. What is the error? It's a runtime error.
It just makes invalid. Or am I?
Okay, so why invalid free there?
Wrong allocator, I suppose.
Yeah, we're free in using another allocator.
Yeah.
So that kind of suck. So if we want to be more safer, then we should probably, save the allocator that we have used to allocate. But of course, that's just personal preference, depending on if you want to make it dangerous or you want to trust the programmer or not. But I think, honestly, I would rather store the allocator myself.
So you save it.
Yeah, allocator.
So you save it like this, like a member house.
Exactly. Go ahead. Because when you have such an API, you risk people misusing it, right?
Yeah.
And it also sucks to give the same allocator, like, I mean, you already know what the allocator to use.
Yeah.
Okay, cool. Now what you need to change here in the dnet function, I think that it's a GPA leak. GPA throw weird error when it detects leaks. Yeah, I mean, I was expecting an error. It's just that before it hanged for some reason. Maybe because I am linking libc for the first time in Zig in this system. Self.allocator.free, yeah. And remove that heap allocator, yeah. Well, not there. That's the init function. Never mind. Keep it, yeah. Okay, no. The init function is good, right? Self.allocator.free, so great. Okay, cool. Now save this and run.
Okay.
Control S and yeah. Okay.
What's this error?
In use local variable. Just comment this out for a second.
Yeah. So it gives errors for unused ones.
Exactly.
Is that like a build? Can you change that in the build?
Yeah, but you can actually suppress that by saying this. If you didn't comment it out, I think. Yeah. But anyways, go ahead, Zig build run. And it works, right? But now our API is more strong, kinda.
Yeah.
To misuse, so we make sure to use the same allocator. Great. So notice here that you could actually use the C allocator easily. So this is basically using malloc and the allocator that alloc functions you would use in C. So this is great if you want. Let's say you're working with some C library, and that library is expecting for you to give it a C allocation, so it would free itself. Let's say, then you would use a cd.heap.c allocator, right? You see what I mean? Okay.
Yeah.
Now let's just use the GPA. So use this allocator here, yeah. Okay, cool. So you asked about arena allocators, right? So there's a lot of allocators in Zig. And in fact, I've never really considered allocators until I learned Zig for the first time. Because it forced me from the start to actually, think about what allocator I'm using, instead of like other languages, which you just use malloc, calloc, and that's it. That done. You don't really think about it twice.
Yeah, I think you can choose them in Rust, can't you? It's like I remember reading about it one time. I'm not actually sure if you can choose them in Rust.
I'm sorry, what you said?
I think you can choose different memory allocators.
Yeah, you can. There is ways to actually change the global allocator in other languages like Rust, C++, and so on. But yeah, it's not really as smooth as Zig, I guess.
Yeah.
It's like there's no hidden stuff. Anyways. Alright, so, but there is, like, for example, Rust. They do have a new allocation API that is coming in, but it's still unstable right now. And yeah, Tunify, thanks for the heads up. GPA, we're creating a new allocator. We have to deallocate it. So defer.
Right.
Defer allocator. Or GPA, yeah, my bad. GPA dot D. Great. But this dnet function, what does it return? It returns some check type. It returns check.leak. If there were leaks, check OK otherwise. So it basically tells us if there was a leak, if we have missed something, right? Okay. So we could use a cdl.debug.assert here.
.assert?
No. Keep that.
Yeah, I know. Sorry. Dot assert.
Dot debug. Cd dot debug dot assert.
Oh, okay. Dot assert.
And you would
Okay.
pass in this here, yeah. But that requires a bool, so we gotta say equals to. Yeah, paste there. Equal to, equal. Now, instead of getting the type of that check struct or enum, you could just say dot, and it would infer, Zig would infer what you're talking about. So dot, there. Okay.
Okay.
You see, you don't have to tell it the enum type. It would just infer it for you from the dot, right?
Oh, okay. Is check? So it would be check.okay.
Well,
Right.
you have to see which namespace it is in. I think it's in the general std.heap.general purpose allocator.check and so on. I think. No, general purpose allocator. Hold on, go back. Dot general purpose maybe. No. Let me see where is it. Hold on, check.
I just wanted just to know, like, it's
std.heap. Sorry, std.heap.check. std.heap.general purpose allocator.check.
General.
Not like that. General purpose allocator. In snake case. .heap.general purpose, because it's a namespace, right? So
I'm only seeing the two options.
But yeah, it's basically, let me type it up for general purpose.
Yeah.
I think
Okay.
cd.heap general purpose allocator dot check dot okay. I think try that.
I'll run them.
Root struct has no member named. Okay, what? Well, it's saying to me that here. Did we say cd.heap? Yeah. What's up with that? Hold on. What? I'm not sure. Is the documentation outdated or something? The std in Zig documentates all data-related script to search for. I need my local version. Ah, I see. Because, you know, Zig is still not released. It's still being worked on, so it changes. Aldrich, Banal Land, welcome to the live stream. But yeah, anyways, but yeah, that is enough. You don't have to anyway. You don't need to do that. So, what's up? I'm good. Thanks you, Aldrich. Thank you, Aldrich. Great. Okay, so what we need next for our tensor? What operation we need next?
Kind of want to clear these values here, just to all zeros, or something.
Ah, you want
just
to clear
them.
We can make a clear function, I guess.
Okay.
After the
I'll call it
dnit.
like zeros.
Yeah, if in
0.
Okay. Maybe you could just call it clear. I don't know.
Yeah. Okay. Yeah.
Then the user could choose whichever to clear it with.
We could just do like set, and then
Yeah, do it whichever you want. Honestly, I don't have a.
Okay.
You need self, yeah.
Okay.
Before that, you need self.
Yeah.
But you see, it's kind of annoying to every time say this, right?
Yeah.
So you could just say const self is equal to this, like that.
Okay.
Now I could use self, right? And here self. And here self. Okay.
Yeah.
In used function parameter. Okay. So what you should do now, I think there's probably some function std.mem for that even already. I would guess so. Just try to do something. Try to use a for loop, I guess. So
I have no idea how to write.
Yeah, let's just use a for loop for now. For, and here you would tell it what you want to iterate through. Self.buffer. For, yeah, go ahead. No, you need the parentheses.
Okay.
Self.buffer.
For.
And then you capture the value here. Afterwards, here.
How would you?
Here.
Yeah.
You do 2 pipes, like closure in Rust. 2 pipes. And here you name the variable that you want to capture. Call it value, yeah. Okay. There you go.
Okay.
Okay, and open the... There you go.
Okay. Would just be val equals...
Okay, and see what the error that you're going to get. Not sure how good are Zig errors, honestly. Yeah, it didn't give you any error, but it didn't... Well, you haven't called the function, first of all, so try to call the function. Yeah. A dots. Okay. What is the error?
Count assigned to a constant.
So?
Okay. How do you make them variable?
I guess you could probably say var. No, apparently. But that's not anyways what we need. You know why? Because when we iterate like this, we're actually getting copies of the values, right?
Oh, okay.
Okay, so we need the pointer, right? So here we say reference, right? As like you do in C. Ampersand, yeah.
Make keywords. Hold on.
And then here a star for dereference.
Okay.
Or not dereference, but like you just basically declare a pointer in some sense. But anyways, there you go. And now you have to dereference it, and you dereference using dot here, dot star.
Dot star.
Exactly, yeah.
Like that?
Yep.
That's how you dereference it? Okay.
Yeah. That's how you dereference a pointer, right? In Zig. It's supposed to be more consistent. I don't remember how, but yeah.
Yeah, it looks kind of weird, but okay. Zig builder on. Okay.
So what's the error that you get in there? Rate it?
Is not. It says pipe const star const slice f64 is not indexable and not a range.
So what do you think the problem here?
Buffer
is const. And why buffer is const? Because self is...
this is... Do I have to set this as a variable or something?
Yeah, because self is const, so you need to give it as a pointer.
Okay.
Okay, now save and run, try it. Type is not index. What the heck? Why? Are you supposed to maybe do it like this? Yeah. Weird. Yeah, anyways, there you go. It works.
Cool. I think it works.
There you go. So, and though I do think there are probably gonna be some function to actually do this faster than. I'm not sure what they
I would
call
imagine
it.
so.
I hope. Oh, zero init. I think initialize. No, that's zeros. Hold on. Not really. That's not what we want. Don't think.
Wouldn't there be a calloc equivalent? You know, that sets it all to zeros.
Good question. Let me check the documentation. But I don't think. I don't. Well, there is no, there isn't. So, though it's probably gonna be in the cd.mem, but unfortunately, languages didn't make a standard for naming their functions, so I don't know what they've called it. If it is any way here, do anyone know if there is a function to fill? Just set a range of a slice, like a range of memory. Mems. Oh, it's yeah. They made it built in. Yeah, I just remembered. So thanks, Jonathan, for that. So memset, right? It's. I think it was in the standard library before, but now it became a built-in function. So this function sets all elements of memory region to LM. This must be a mutable slice. Yeah, I used to scd.mem.set. I see. They're not sensitive constants you should use. Oh, interestingly, for securing zeroing out sensitive constants from memory, you should use scd.crypto.utils.secure0. That's cool. Anyways, yeah.
Does that work there?
Try that. I don't remember how to use Zig. And there you go.
I think it works.
Yeah.
I'll try.
Great.
Try with a different values.
Okay, great, man. So what you want to do next, right? And one note though, when you have, well, actually until we have another function, then I can explain it. But yeah, so what other function do you want to make right now for your tensor?
Let's see. We could. We could do some maths now. Well, see, if to do maths with tensors, you need to know the shape of the tensor. You know what I mean? So if is it a 1/10 tensor? Is it a 2/5 tensor or something? Do you know what I mean?
So I guess you need generic over the dimensions, right? So, right? Like it could be a 2-dimensional array or 3-dimensional array or 4D, right?
Yeah. But we also know, like, we also need to know, like, how many rows and columns there are. Do you know what I mean?
I see. Interesting.
So we can make like a shape struct. Like that's what I did in the original recall.
Okay, I'm not sure if you can actually do that using. Yeah, so we could just do math, I guess, for that instead of doing generic magic, meta programming magic. Yeah, okay. I think so. You could have shape and then use mathematics to index into the array, right?
Does this Zig has tuples, doesn't it?
Two?
Tuples. It has like tuples that we could use, doesn't it?
Tuples.
Yeah. Did you say it did? I thought you said it did.
Yeah, it does.
I
don't know how that would. Hold on. So, do you want the shape to be a compile time or?
Yes.
Time?
Compile time.
I never done that in Zig before.
I don't know. Like the way I did it in the original repo was it was just a struct that held
Yeah, make that
Like
struct.
there's a shape.
Show me how that
There's a
struct
shape.
is.
There's a shape struct.
The easiest solution I think about right now is to do some math on dependent on the shape and the buffer, and you know the buffer would stay as a one-dimensional array or one-dimensional slice.
Okay. Yeah, we could just keep it as a one-dimensional.
Yeah.
Yeah, that's fine. Okay. So we could just do like.
Especially that it's
You
a
only really need.
slice. Anyways, go ahead. So Fn, I think we want an index function maybe first, depending on the shape, right?
What do you mean an index?
So you need first of all, I think a new field called shape, right?
Okay.
So the dimensions you said it's gonna be a compile time, known in compile time, right? The dimensions.
Like, well, no.
Like, is it a three-dimensional tensor 2D?
It would be like, no, it would be runtime, I think, because you pass in the type, because it's almost part of the type of the tensor. It would be like.
Yeah, so what I'm thinking, if the shape dimension would be known at compile time, then we can use an array, right?
Yeah. Yeah.
And then we could pass in here a constant, right? Comp time. Go ahead, comp time.
Dimensions.
Yeah.
Something like that.
I'm not sure if that's the naming conventions of Zik, but yeah. And the shape of the type would be usize, I think, yeah. Okay. There you go, now you have the shape.
Yeah, that's good, yeah.
So I think you would need an index function first. That would basically use the shape to index into the function. So fn
okay. Actually,
index.
When do we need to change the init function? When do we?
No, we have that at compile time. The dimensions. Oh yeah, my bad. Yeah, true. Go ahead. Sorry. Yeah, take in the shape.
So it would be just shape.
Yeah, the exact same thing. Dimensions, usize. Exactly.
Okay. And then dot shape. Just like that.
Yeah.
Okay.
Now to make your job easier, first of all, maybe work on a index function. I know the math of 2D array, but I'm not sure how you would generalize that. Never done it before. Index self. And you would need the not shape. Yeah, we need the index, and it's gonna be like dimension usize, right? I think. Yep.
Yeah.
And the type would be the same as the shape, I think.
Well, okay, yeah.
Do you have another idea? I think that's the way I would do it, I believe. I've never done it, though.
Yeah. I think, let me just think, like, if we...
turn a reference, I think.
Yeah.
So, pointer...
to...
scalar.
Yeah. Okay.
There you go. Okay. And now what you would return here? Indices, yeah, that's good.
Let me think. We'd have to like... we'd have to loop over the indices to get it.
Okay. I'm not sure honestly how we would do a generic way. But I know how we would do it in 2D, for example. You would say something like self.buffer, I think. You would say indices Maybe 1 times shape 1 plus indices 0. I believe that's how you would do it in 2D, and you would return a. I mean, let's start with that. Let's start with the 2-dimensional thing and see, make sure if that works.
Okay. So in inits, we just do like that. Does that work? In Zig?
Why didn't it accept it? Maybe you need a dot or what? Hold on, I don't remember how do you make an array.
Oh wait, we have to pass in like
Yeah, I
there.
think.
So that's what you do.
Yeah, I see. Okay. So you would basically do it like this, I think.
Oh, okay.
Okay. Try that.
We'll just run that one.
Oh, German. But you haven't used that function yet.
Yeah. Okay.
You could use the index function. Now,
so if we
self.index. A.index, right? Try it.
Yeah.
Index. And yeah, make a array there. No, not there. Here.
Yeah, I know. So mistype.
Right now, just hard coding the formula to a 2D for now. So whenever I start a new problem, I just start with something I know. Yeah,
that's fair.
Or something more concrete, or yeah. And then I try to generalize it. Okay, so what it returned? Where is that?
Well, we're not returning this. Actually, why doesn't this give an error? This should give an error, shouldn't it? We're supposed to be returning scalar.
No, we're returning a reference, yeah.
Do we not have to? So we don't need the return keyword. I thought you said we do need it.
Oh yeah, my bad. Yeah, return. My bad. Yeah, I'm used to Rust. Go ahead, return.
But shouldn't it? Why doesn't it give an error there? The compiler.
Interesting.
Why doesn't it complain about that?
I'm not sure why. Maybe you didn't save.
Okay, we're getting an adjuster.
Yeah, dereference. Oh. Oopsies. Try now. Try again. Zig build run again. std out. Suck. Okay, cool.
Okay. Well, we're getting. We should probably.
Yeah. Sorry.
We should probably set it to like. We should probably make another function that like gives it a range instead of just all 5.
I'm not sure how Zig devs would do it. Like in the community, is there any standard for this? But as a Rust user, I would say this. I would have 2 kind of functions, one for mutable access and one for, you see?
Yeah.
And in fact, since that's the case, we don't even... Well, actually, this is supposed to be const. And that's supposed to be mutable, yeah. And now... And by the way, here I didn't really try to even use a pointer. You know why? This wouldn't actually copy. The compiler would determine if he wants to copy it over or use by reference automatically, depending on the struct. You see?
Okay. Yeah.
Unless if that got changed, I have no clue. So self and scalar, yeah. And it's gonna be the same thing, I believe. It's just that right now, if you try to use index, so yeah, Ben, let's just do the same exact thing, right? Is equal to, try this. Zigbel run, yeah. Cannot assign to constant. Yeah, you see? It's given constant. But if I use index mute, try that. But it's still 5. Interesting.
Well, in index mute, you're not assigning anything. You're just, or oh yeah. That's weird.
Should work. I mean, it's the same logic.
Shouldn't it be like
Not sure what's happening here. Let's try something else. What? I'm not sure why this doesn't work, but we could just use, like, instead of set, maybe we should call this fill.
Okay.
And I don't know why this doesn't work, honestly, but let's just do it the regular way you would do it for now, I guess. Get and set.
Yeah.
I mean, get have worked, right? Cause I don't know, man. Yeah, let's just do it in a regular way anyways. Turn. Although this would be bad if scalar is, you know, takes a lot to copy. Not cheap to copy, but anyways. Get void, yeah. Value scalar, yeah.
And then a one return, it would just be
not really, yeah. Okay. Not return, yeah. And remove the reference to. Equals to value. Okay, so that's way simpler. Try that. Well, where's our set function and get? Oh, I think I removed that. Hold on. Let's make this get. And try that. Okay. Now if we try to do set a dot set this indices with the value, say 10. Try now. Yeah,
that works.
10.
Okay, cool.
I don't know why the other way didn't work, but there you go. So okay, great. Now we need honestly some way to format this to print this. But how would you actually print a a tensor of like arbitrary shape? Good question.
Yeah, I don't know. Yeah.
How does Python does it?
Python, like if you're using something like NumPy, they just format it pretty nicely. But I think that would just be it's
But
kind
like
of a
if you
pain
have
to do.
a 3D tensor, how would you do that?
They'd like space it out, so you'd have your like 2D grid, and then they'd have like a new line, and then another 2D grid, and so on. Do you know what I mean? So
Yeah,
like
but and
each
then
slice of the
yeah, that
cube.
you can get away with that with 3D, but then 4D and 5D and
Yeah,
so on.
they basically stack it. So like yeah, I know it's hard to do
Sweet.
it after 3D. Yeah, but we don't really need. I mean, honestly, we probably don't even need. The most we
Okay.
probably need here is like 2D tensors.
Okay, so the
Like
shape, should we start with 1 or 0? So
uh
here right now it's basically that it's kind of like the x is the first and the y is the second in the shape. Is that right? Self.shape.
uh,
And in fact the shape, should it really be 1?
see, it might be one dimensional, so
Hold
it would
on.
only have.
How to index oops, to an arbitrary shape. Well, how do we even search about this? How to index a 1D array with of arbitrary shape? Or honestly, let's check out NumPy shape documentation, maybe. The elements of the shape tuple gives the length of the corresponding array dimensions. So, np.shape. What? Bruh. Array shape. Well, hold on a second. We can make a Python file. Try ourselves.
Okay.
So you do know some Python, right?
Yeah, I do. Yeah.
Okay, cool. Can you make a new file? Maybe in the root? I don't know.
I'm not even
Call it
sure
whatever.
I'm not sure I have pip installed on or Python
Ah,
installed on this machine actually.
okay, never mind. Let me do it. You have my terminal, yeah. You have my terminal.
Yeah. Yeah.
Try have them installed. So just create a new file, just to test stuff up in Python real quick. Or I could do it. Should I call, I don't know, test.py. Okay, do you see my file? The Python file test.py?
Yeah, I do. Yeah.
Alright, let's try this. I'm not a
Oh, sorry.
Python
I
programmer.
started typing.
Import NumPy. Are you familiar with NumPy?
A
As
small bit.
NP,
Yeah.
yeah. Okay. Try to see how that works. So do kind of like the same thing as I did there. .git, .sit, stuff like that. So tensor, var tensor.
I'm just gonna.
Or we could use AI maybe. Could use AI.
Yeah, go on. Yeah,
Hold
yeah.
on, let me see.
Use ChatGPT.
Create a tensor. Oops. Create a tensor of arbitrary dimension. Oh. mp.random.rand in a given shape. Oh, it's random values. set to 0, or let's say set to x. Well, let's say var x is equal to, oh, what? X equal, okay. And I guess you do it like this. Turn any array given shape a type filled with fill value.
Okay.
Cool. Okay, what if I print this? Yeah, exactly. All right. 10, 10, 10, 10, 10. Okay.
Have you had a dimension?
And how do you...
Wait.
So let's try 1, 2, 3. Well, not 1, 2. Let's go with 2, 3, 4. Try.
That gives you 2 3x4 matrices.
My brain have crashed.
Yeah. we really don't need to do like if we just have.
Okay, let's just have like, 2, 3, 2, 3, right? Now, how do you actually index into this? Get item. Oh crap! Get item and index or 1, 2. Yeah, sure. Okay, so you just do it like this.
Yeah.
Okay. And I guess I could say something like this, right? And so what we currently have is kind of something like this, I think.
Yeah.
1, 2. So, we got 1, 2. So 2 corresponds to what? So this index right here. To which shape?
That's the least.
So the y, I think, like. So this, yeah.
Yeah.
And this. Well, hold on, no. No. This actually corresponds to this. So if I say 4, because it starts from 0. Okay, yeah. So this basically corresponds to this, and this corresponds to this. Okay, interesting. So how we would make that work? Well, what if... let me see what the AI would actually do. Would they do anything here? That's what the AI seems to have generated.
Can it write Zig?
I don't... not that great at Zig, but like...
Yeah.
But yeah. But the thing is, where's the 0 shape? Yeah, that's just... Okay. So how are we gonna do this for arbitrary dimensions?
Yeah, that's the thing. See, I didn't even implement this in the repo yet, so we could just leave it.
All right. Let's see. I think we could start with index, maybe indices 0. And the... I guess what I'm... Oh. Yeah, you see it's bad at the dimension. Well, in our case it's shape. And what the heck is I? What the heck? Self dot shape and self dot, well, indices. So here we got the index and the shape, I think. And you would basically, I think it's, I'm not sure what the heck it's doing there, but I would say plus equal index times shape. Capture index shadows. Oh, I see. Let's call this, I don't know. Let's keep it as that, I guess. And, or, nah. I hate shadowing. Or 1D index, yeah. Linear index, okay. Oh crap. Maybe that's it? Is it? I do not know. Hopefully I'm not saying nonsense here.
I have no idea. Yeah.
Let's ask ChatGPT. Well, yeah, go back and see if we're doing a good job. Let's see. Is this correct? Let's see what the AI would say. Logical error. Okay. Calculation to consider all dimensions of the array, not just the first one. False, not just the size of the current dimension. Here's the corrected version. What? I'm probably missing something in my logic there. In this corrected version, try used to keep track of the product of all sizes of subsequent dimensions. This ensures that the linear index is correctly for multidimensional arrays. I mean, this is what it's saying we should do, but I'm not sure if it's any right.
I have a quick question then.
Yeah?
Do you see the for loop?
Yeah?
Is that so? You're giving it to like you're giving it to like arrays, and it's looping over both of them at the same time.
Yeah. Zip.
Okay,
Basically
okay.
zip, right.
Yeah, okay.
It's zipping through them.
Yeah.
So linear index, and we have a stride. This is what the AI said. Linear index plus equal index times stride.
Yeah.
Which is going to be 1 at first. Really? And then stride times equal to the shape. Well, it's not really the shape here. It's it should be called dimension, I think.
Yeah.
Or size, maybe.
Yeah, whatever. Yeah.
Oh, let's call it. Let's see now. The AI would it say incorrect again for its own code? Is this correct? Yes, the Z code you provided is correct. The function sets a valid specific index in multi-dimensional array, calculates the linear index correctly by considering all dimensions of the array. Stride variable is used to keep track of the product of the size of all subsequent dimensions. This ensures that the linear index is calculated correctly for multi-dimensional arrays. I mean, it said it's correct, though I would take it as a grain of salt. But I mean, we could work with that for now, and right?
Yeah.
Okay. But let's actually make another function to calculate the index, right? So, yeah, say, well, so it would basically, yeah, go on. It would basically take the indices and would give you back the, well, sorry, it would, hold on, what? Yeah, it would get the indices and it would give you back the one-dimensional index.
Okay.
So we'd only do the calculations basically, so we could reuse it in both kit and sit. You see?
Yeah. Wait,
no need
oh,
for
so we're returning.
Yeah, we're just returning the index. The one-dimensional index that we're gonna calculate. And what's gonna return?
U size?
Exactly, yeah. There you go. Now just take this code. Well, only this one, yeah. And the index. Yeah. And now here what we should do.
Isn't the naming not gonna match up?
I'm not sure that's correct. I mean, there's no other index. Oh, what?
The function name. Will that mess it up? Function name.
Is it? Interesting. Well, maybe say I.
And yeah.
Though I don't know why it would do that, but anyways, whichever. So, okay, cool. Now, here what we should do. Self.index.
Or no.
Indices directly, yeah.
Jeez.
Yeah.
Okay.
I'd also just do it directly, maybe.
Yeah.
Oops.
You can do that if you want.
Oops. What the heck is going on? Yeah, I'll just do it right like this. I don't know. That both works. So, okay. And get, same thing. I think. I'm not sure if this would work out, but let's just maybe do the same thing as we do in Python here. So we're making 2, 4,
Yeah.
2, 4, comma 5. Well, 2, 4, and 5 is what we fill with. And then we have set it, yeah, we have set it what? Yeah, 1, 2 to 10. Set 1, 2 to 10. And let's just print A, honestly. Oops.
Yeah.
A dot buffer. Let's see how it is. Try. Sig build run, yeah. Cannot format slash others. Ah, I see. So basically, it doesn't know if what. But hold on, why? Interesting. So just say any.
Okay.
Because that's not a string. We want to just print it.
Oh, okay.
Values. Try. Try again.
Yeah, there you go. Well, is that the correct one now?
Good question. So you see 5, 5, 5.
I think it's 1 off. No, see, R1 is slightly different.
Okay. Well,
we still only have. See, we have 10 values. It should be like 8.
yeah,
No?
yeah, that's true.
Actually, so in the init, what we should do is
Yeah,
we should
true.
get rid of
My
size.
bad. Yeah, there you go. Go ahead, remove that.
And we should calculate size.
Yeah, that's true. From the shape.
So, you size is equal to. See, now we have to like loop over all of them, don't we?
Yeah. So just
I'll
say.
just set it to 1.
Yeah.
And then for shape.
Well, what NumPy calls that? Hold on. Yeah, you could just go on while I look at it.
It's probably not the best way. But
they call it length of the corresponding array dimensions.
Yeah.
Yeah. So just the product, yeah.
Yeah, that should work.
Okay. And
let's try that.
Well, no, you haven't done everything yet. You should plug in that size. Well, you have done that, yeah. Have you changed the other one? Yeah, you did. Cool. So go ahead. Cannot assign to constant, so what should
Oh, yeah.
Variable of type comTime int must be const or comTime. Basically, when you say 1 like this, it think that you're talking about a comTime value, comTime integer, which is infinite. Well, not infinite. It's like a big integer, you know. But in our case, what we really want is just usize, right?
Oh, okay. So
Because
like
there
an
is some
value.
interesting ways to var size equal as type int cast 1. What does that is? Oh, I think it's fine like that. No, I think it's fine like that. Zig build run you. Try again. And print a
I think that works
Python
out.
one too now. So
Yeah, I think,
5.
I don't think that works.
It's 1 by off by 1, right? Or isn't it? But like what?
It's supposed to be 1 over, isn't it?
Or is it just the format is different? Well, here's the case. Here's what we could do, right? So what I'm gonna do actually is make a hold on. Yeah, let's do this. Okay. For I in range, right? And you let's say from to 2, right? And for G in range 4, and then print T I G. Yeah, do the same thing in Zig. Let's see.
Okay.
Because that would be easier to compare because it would be exactly the same. So instead of printing it this way, do that the one that I've done there.
Yeah. So
4, yeah, and open the things, right? The parentheses. And in Zig we have ranges, so you can do
so like 1 dot dot, or
yeah,
what is it?
yeah.
Like, is it like Rust, or
It's kind of like Rust, I think. Yeah, try that.
so going from 0 to 2?
No, yeah, exactly. And you would get the I. Four, and then you get the G.
A dots. Wait,
Oops, I moved that. Okay.
just print it. How do I? Okay, so
Yeah, no need for these. Just the. Oh yeah, fine. To keep it. Yeah, fine. And there you go, comma, and you would need to pass in a tuple. Dot. And yeah. IG. They'll get.
like that.
Yeah.
Does that work?
Try. Oh, let me remove this. Try now. Clear and. Add a new line. Do we have print line? Oops. No, we don't, I think. So. Okay. Try. And the Python test one.
Yeah.
And
Okay, so that works.
that seems to be correct, yeah?
Yeah, I think so.
Okay, let's try some other tests. Maybe let's even add another dimension just to make sure. I, G, K, I guess. In range. So instead of 2, 4, and blah blah blah, I'm just gonna say shape is equal to this, I think. Shape.
Yeah.
And then here shape. Is it dot? Wow. How do you access a
Yeah,
tuple? Like
yeah,
that?
that's how you do it. Yeah. Yeah.
Okay, we're learning Python too.
Yeah. Don't you have to do J as well? Or because
Hold on, my bad. Shape 2 and shape 1 here. And let's just range, yeah, true. Let's say 2, 4, 5, I don't know. Let's say 1, 2, 3. And and let's just keep track of the I.
I think that's gonna mess it up.
Hmm?
Or because you're assigning the I to the value in shape or in range, do you know?
What do you mean? I'm just basically
'Cause you're
keeping
doing
track
four,
of which index in linear.
but you're already doing you're doing for I in range.
Oh,
You know?
oh, I see, I see. Let's call it
Yeah.
index. Naming's the hardest in programming. Index.
Yeah.
Okay, cool.
Okay.
And let's Python test.py. And we got it in 34. Yeah? And now
Yeah.
we're gonna do something similar there, right? So the shape is 2, 4, 5. I'm gonna copy it over. And we're filling with 5, yeah. And we're just gonna say 1, 2, 3, 10. 1, 2, 3, 10. Hopefully this would work. 4.
Now we have to do another for loop.
Yeah, actually, let's store this as the shape, just like we've done in Python. Maybe. Is that even possible? I think so. Let's go give it the shape here. And shape. I think the same thing, yeah. Shape 0, shape 1. Shape 2, okay.
And do you want index as well?
Yeah. Well, our index is equal to 0. And yeah, go ahead.
Oh.
And used capture.
Okay, will we try that?
Hold on. Okay, 2. Hold on, what the?
Well, we don't need to print out the J in the candy.
Yeah,
We
good.
just print out index like in
Okay,
Python.
sure. Okay, try that. Ooh. Expected type to usize found struct. How do you declare a tuple though? That's a good question. hold on, let me go to the reference. Tuple. Seems like you just say constant, that's it. So what's up?
Did you figure it? Did you get it?
Hold on, expected type 2 usize. Found, oh, my bad, I see. So here we're actually given a tuple, but it's expecting a, interesting. Should we go with it? No, thanks. Okay, well, you know what, let's just, who cares? Anyways, go ahead. Clear. Oh, yeah. Like this. Try now.
I actually really like that feature, like
Yeah.
just passing in types like that. It's way more painful in C.
And I think it
but yeah,
works. Index 34, that's where 10 is. And in Python, it's 34 too.
Okay.
So I guess this probably works.
Yeah, I think so. Okay.
Yeah, great. Okay, so what we need next?
We should start like some arithmetic, like adding and
Sure, make an add function and so on. Yeah, go ahead.
So.
Well, the AI saved the day when it comes to that index thing.
Yeah. So this is going to take in self, and then another tensor.
We don't need this.
But like, it needs to take in a tensor, but the tensor now we have to check the sizes of each tensor to make sure they're the same size. Do you know?
Yeah. So.
Or the same shape. They have to be the same shape.
Hold on a second. So I don't think tensors of different dimensions would be compatible, right? That would.
Yeah.
Yeah. So that's great.
We have to compare their
that
shape.
compile time is out of the way. Great. Yeah. So we just have to compare the shape at runtime.
Yeah.
Okay. Go ahead.
Do I just put in like other?
So now we really need to know what could be addable. So add, what is it called? What is it? Tensor. Okay. Tensor addition. I mean, you could just go on.
Do I just put in tensor like that?
Well, no, you have self. It's the same type. As long as it's the same type, yeah. Otherwise, you could, if it's like another dimension, then you would basically call this function again. Tensor.
Okay.
You see?
This would have to be a pointer, wouldn't it? Because you don't want to.
No,
you don't want to.
What do you want
copy.
here? Now, what's the semantics you want to do? I think you want to basically add it in place, right?
I want to. That's a good question. In the
do you want
repo,
to add, or do you want to give a new one, basically?
In the repo, I made a new one. I think we should make a new one. Actually, yeah, we have to make a new one.
I feel like it's better to do it in place since you're doing an allocation, and then have a clone function which basically make a new copy.
Well, wouldn't that change the original tensor? Because when we're doing the backpropagation stuff,
yeah,
we're gonna have to like save tensors and different things.
Yeah, but basically, since the tensor is kind of not a cheap thing to copy, what I'm thinking is you would support both semantics by having an add function that mutates, and then a clone function that would make a new copy of the tensor. See what I mean?
But would you mutate one of the
It would
tensors?
mutate itself and keep the other intact.
But see, in the like further down the line, when we're doing backpropagation, you're going to want to save the tensor values.
Yeah, we'll
Do you know what I
have
mean?
like an fn copy or fn clone that does the copying. So you would say add first, then you would copy, and you get a new copy. Well, actually, you would get a new copy first, then you would say dot add, right?
But you'd want
So you'd say a dot copy, right, or clone dot add. You know, so you wouldn't affect a at that point. You would get a new copy, right? You see what I mean?
Oh, okay. I guess you. Yeah,
so you would support both semantics.
Okay.
But the other way around, you wouldn't support the mutating part unless if you make another function again.
Okay.
Yeah, you got the point. Okay,
Yeah.
so I think that's gonna be the best way to go about this case.
Okay.
So other self, we just pass it by reference or by value. That's the job of the compiler. Doesn't care. You would do the best you can. And self, we need a by reference because we're gonna mutate it. So go ahead.
Void. So we should have another function that is like same size. Do you know?
Ah, it's the same size.
Yeah.
You don't need the reference there because you're not gonna mutate it. You could probably say std.mim is equal. But yeah, go on. It's same size like this.
Yeah.
Right, and
what's bool? Is it just bool or what is it?
Just first of all, open the. You can use a for loop, but I think you would better off using EQL. I think it's called. Yeah, std.mem.equal.
What is it? Mem.
.equal. I wonder if there's an EQL thing. No. Okay. Okay.
Shape.
Without a B. Without.
Yeah.
It would return that.
Oh my god.
It's same shape actually.
Same shape, yeah.
Yeah, and did return bool there.
Bool.
Yeah.
Yeah.
And now what you would do here?
Actually, this would return an error. Otherwise,
well, it depends on what we want to decide. Do we want this to be a hard error or a recoverable error? I think honestly it's better to make this as a hard error.
I think it should panic, yeah. I think.
Yeah, okay.
So if how do you do it? Is it like not?
Try. So.
Is it like, how do you, is it like?
To be honest, I don't remember. Yeah, panic. Right. Then you would give your message there.
Actually, we should do it in here in the is same shape.
Not really. I mean, the user may want to actually check if it is the same shape.
Well, it's just that we're gonna have like multiple arithmetic.
You could say fn check same shape, I guess, or assert same shape.
Okay. Yeah.
Then you would have that, right? Not same shape, self. Shapes needs to be the same. No need for shape at the end. Like here.
It shouldn't return anything. It just should be.
Yeah, no, it doesn't need to return anything.
Yeah.
And for that, I wonder if there's a type. Ah, yeah, void. Yeah. Okay. There
Okay.
you go.
That works.
Now we do the addition, yeah.
So we just have to do it. It's just going to be element wise. So we just add. So we can just go. So top buffer. Or actually, we can do. Um.
You could say LHS and RHS, left
Yeah,
hand
yeah,
side,
yeah.
right hand side.
Yeah. Yeah.
That's what I'm used to as a Rust programmer.
Yeah. No, yeah. That's better.
So you'd say LHS directly. No, you don't need buffer right now. You're already iterating through it. LHS would be the value itself. But the thing is, you want to mutate this, so what you need is you want to mutate that. Because right now we're getting it by value.
Yeah.
So you need to add here what? Here. What you need to add in my cursor?
Oh, what is it again? We did this.
Star, basically.
Yeah.
Walaikum salam, OG Gear, welcome to the stream. And then what you need to do here, because it's a pointer right now.
You dereference it.
Exactly. And how do you dereference in Zig?
Yeah, it's so weird.
Yeah.
Oh my god. There we go.
Okay. Try that.
So, I'll get rid of this. We need to make another tensor now, don't we?
Yeah. RAB. That wouldn't work. I don't know how to turn a tuple into an array and back. There's probably some function for that.
Just leave it.
But honestly, just keep that in line, yeah. And B.
Yeah, that works. Okay.
B here. Okay. In Zig, we don't have any operator overloading, we just use the function.
Yeah.
What's the error?
I have to put in.
Expected type main.tensor found. Interesting. Interesting. I don't think we want to dereference this, or are we? No. You know what? Just use it like that, yeah. Go on.
So
Yeah, compile right now, see? I've added the star and that's the same shape.
oh,
Expected type. What? Did I save? Hold on, zig build run. What the heck? I've changed it. Oh, I see. So that's 2. Okay. Array literal requires address of operator to course to slice type const use size. Yeah, so what it's saying here, I think your terminal is all dumped right now. Clear zig build run. Yeah, hold on. Yeah, you use the last command right now. Go ahead and use the last command.
sorry, just
So what's the error?
array literal requires address of operator to course to slice type.
So what's the problem there? We have the shape. What's the type of the shape? It's an array. And
yeah.
equal function is expecting a slice. So to coerce an array to a slice, you add the address of operator here.
Oh, okay, yeah.
The same thing is here.
Yeah, I got it, okay.
Try to compile now.
I think that works. Those are all 11s.
Though it's kind of weird what's the format of zig. I don't know how to
I know,
change that.
yeah, it's the scientific yeah.
Suck.
It's weird, but it works.
Yeah.
So now we need to make that copy function.
D? Oh, Jonathan said D. You added D there. But hold on. How do you do it here? D like this? Try? I don't think that would work. I think we need to go through it. Yeah, that actually works. Let's go. Nice. Thanks. So you just say D. You see?
Yeah.
Okay, great.
Okay, cool.
So now you want what? Which other function now? Sub? Let's say.
Copy. Well, we need copy.
Yeah, okay, go ahead. Copy fn. I would call it clone as a Rust developer, but since this is Zig, just go with copy, I guess.
Okay. Copy.
Self. I'm not sure what's the Zig community conventions. Yeah. Culture. The Zig culture. Okay, copy. Great. Okay, so first of all, what we need to do. Well, actually, you know what? Instead of copy, maybe we need first. Well, hold on a second. No, hold on. Like maybe we could make a function called copy from, and you would give it some tensor to copy from. So it would basically use init and then copy from a tensor. So yeah, like basically the idea is from tensor self. I'd base my of array list managed. Yeah, I actually forgot about that completely. That's a good point. So instead of doing the allocations ourselves, you see, Can you hear me? Yeah, we use an allocated buffer and so on.
Okay.
Instead of that, since we have owned memory, we can basically say buffer std.arraylist managed. Oh, I think it's basically ArrayList. Yeah, and there's the unmanaged version. Com time t type scalar. You see where I'm typing, by the way?
Yeah.
Okay, so the field buffer std ArrayList scalar. So both the allocator and the. So you remember when we didn't have the allocator field, and we had to pass the allocator to the init? That's what it's called, the unmanaged version, which means that you have to pass the allocator yourself, right?
Oh, okay.
To the dinit. But I think the regular one does store that. Oh, I mean, you could look at ArrayList manages on your Tensor. Oh, but I think ArrayList would make sense here, actually, isn't it? Yeah, I think it would make sense anyways.
Well, we don't really need to. It doesn't need to be growable. Do you know?
Does that matter? Let's see.
It doesn't really matter. It doesn't matter, but I was just saying.
I'm not sure what would a Zig developer do here. So it contains items, capacity, but I mean, you may want that at some point. And like, since it's, you know, owned memory, I don't see the problem why.
Yeah, it's fine. We'll go with that. So.
I don't know.
Okay.
But yeah, maybe let's just stay with this for now. Fine. Let's just stay with this for now. But that's an option. That's an option that you.
Yeah.
Okay, so copy from. So from cell, yeah. So how are we gonna copy from the values? Of course, we gotta make sure to assert same shape. Yeah, go on. Copy from assert same shape.
So.
And what you would do here. So you basically would copy all the values from that from buffer, like from the from buffer to self.
Yeah.
So we could use std, well, what is it called? Mem copy. There's mem copy, yeah.
Copy.
You have mem copy here. So yeah, go ahead.
Self-buffer. Maybe. Or yeah, from the buffer. Something like that.
Yeah, there you go.
Is that it? I think, is that it? Yeah.
And now let's say we want also copy function. Yeah, what you gotta do now?
Oh. You wanna?
We're gonna make a new tensor first of all. We're gonna initialize a new one, yeah.
So.
With the same shape. So go ahead.
It's just
const. Self.
Oh yeah, self.
Dot. Dot what? Self dot what? Yeah. The shape, what is the shape? Yeah, self dot shape. Well, not allocator. Oh, my bad. Go on. Okay.
And t dot. Yeah, copy. Self.
Now, this is good, but I don't think the Z community would like this to infer the allocator. I'm not sure. But I think I would rather, since this copy function, allocate, we would just pass it another allocator. So, comma.
Okay. And then what should that be? Type.
std.mem.allocator.
Yeah.
And there you go.
Okay. And then, so we could do.
And hold on, defer. A memory leak.
Oh yeah.
And you need another thing too that can return error.
Wait, if we're doing defer, if we're doing deinit,
Yeah.
how does t get returned then?
Yeah, that's problematic. So we have error defer for that. You see?
Okay. Okay. Well, what's this new keyword now? What does that do?
So that would like just like defer, but it only runs when the function returns with an error.
So do we have to return this with an error?
Yeah, because
Like
self.init what you should do here. Try.
that? Oh yeah. Okay.
And error defer what?
T dot d init.
There you go.
Okay. And then
What I don't like about these runtime checks is that right now it's not clear which function should check for the assert same shape and which one not. But honestly, since I would just use memcopy directly, I think, and do the assert same shape, I think. But hold on. Oh yeah. Well, what? No, my bad. Never mind. We don't have two here. Yeah, it's just a unary function, not a binary one. Okay, cool. Go ahead. What's up now? What's going on? Use of undeclared identifier from in. Run again because I done that thing. Yeah, just run again. Clear and. Okay, what's up? Expected type mem. Yeah, you need to give it mem allocator here. Oh well, here I think. Yeah. Or I don't know. Yeah, go ahead.
did not save.
Try. Yeah, run. Clear. So say clear and semicolon zig build run. So you don't have to do it twice every time. So clear, no. Say clear and then a semicolon and zig build run, yeah. You see it in one command.
Yeah.
Okay, so what's up now? No field, remember, named add in. And also try here, because copy could fail. And you probably need to do that before adding.
Yeah.
Okay. Value of type main tensor ignored. What? Copy from. Oh, this is not supposed to return self void. Okay.
Did you
Yeah, go ahead. I just made that void, yeah. What's up now? So what is the error? So it's basically
Struct
saying that
type.
this is not mutable. So how can you fix this?
There. Which one? Which area are you looking at now? The struct type.
So line 96, I'm highlighting it.
Oh yeah.
So it's basically saying that this is immutable, not mutable, and it needs it mutable. It needs it mutable, sorry. So we can make it into another variable first, then you use it.
Oh, okay. So
Don't need the parentheses anymore. Okay. Alright. Type void does not support field access. Type void, oh yeah. This doesn't return anything, this does it in place. So this should be T basically. Try now. What? Expected type, main tensor found. Main tensor. Copy from. Can we do this? Try. Expected type found const. Ooh. Oh, well, assert same shape should be const actually. Yeah, but like, yeah. Try now.
oh my god, come on.
Expected type main dot tensor found const main dot tensor. Oh, I forgot these consts. Like I honestly. Okay, go
Try.
ahead. Oh crap.
This is
Yeah, what is going on? I know. What it said?
it like it does it correctly.
But what is the problem? The error. Leak. Memory leak. Where is that memory leak?
Yeah.
Where are you allocating stuff again? Without deallocating.
Oh, we have to.
You see, it's pretty clear since you're passing the allocator, it's pretty clear.
Yeah. Defer t dot d init.
Okay. See, when a memory leak happens, the allocator tells you when you de-initialize
Yeah,
it.
yeah, that is pretty cool. Okay, we have add.
Okay, so how would you add? How would you? I wanted to say how would you add another function sub? It's an add function too, but anyways. All right, so yeah, add another function now. Fn sub.
I think so. I think we should implement because you don't really need sub.
What you need?
We need
Negate.
yeah, we need negate and we need mul.
Okay, let's start by mul. Let's start by mul.
Okay.
Just copy the code before. It's also a binary function, so it's gonna be the same thing. You're gonna change one thing.
Okay. And then
And you're done.
I'll just add. This is slightly different though.
But hold on, before that, you notice that here we're copying code, right? So what
Yes.
you would suggest we need here from other languages? There's a pattern that we could do here because we have, you know, multiple code. We could use a lambda, right?
Yeah.
But unfortunately, I don't think Zig have a lambda.
Does
An
okay.
official
Yeah.
one at least. But there is a little way to do it, which is function pointers.
Yeah. Okay.
So we could make an f function here before add called elementwise.
Okay. So.
No need for f, elementwise, I think. Or combine elementwise, I don't know. Yeah. Call it whatever. And then, so you would basically get self and other, so it's basically binary, right? Binary function. Takes 2 arguments, and also it would take a function pointer.
Yeah.
So it would be fn. Okay, so the arguments would be scalar. Scalar? Oops. Oh, but hold on, that's the f, right? Expected return type expression. And what we're gonna return here, void. And used function pair. Okay, try this.
Okay.
So we're just gonna copy this code. Yeah, F, as you were doing. Actually, hold on. Fn scalar, well, LHS. I think we better do it like this, maybe. Then you would just do, I think, this. So avoid copying, I think. So yeah.
Okay.
There you go. I'm not sure if you can do this in Zig. I think you can. But try to compile this at least.
So, just pull this out.
Yeah, Zig build run, go on. Okay, it seems to compile, but we haven't used functions. By the way, when you don't use a function in Zig, it actually gets compiled out, so sometimes you wouldn't even get the errors.
Oh, okay.
If it compiled, because it didn't compile in the first place. So that could be happening here. Either way, let's, so in our add function, we can actually do element-wise, let's say. Or, yeah, try that, go on. So here, say self.element-wise in add.
So.
Okay, yeah. And what's the f? You would create a function with that arguments, right? Create a function outside, or, well, I mean, yeah. Create a function just here, I think. Let's just call it f for now.
And then, what will I call it?
Just call it f for now.
Okay.
And it should have this kind of, so kind of like that, right? Oh yeah, that's good too. Scalar, okay. And LHS, right? There you go. Go ahead. You know, implement the add. Well, not return. We don't return anything. Actually, this is void. It's mutable. You gotta mutate it. So basically, this should be void, right? And go on. LHS dot. LHS dereference
But wouldn't
plus
you need
equal.
to change like this as well?
Oh yeah, that's true. Go ahead, void. Oh well, yeah, okay. And here we're gonna return F. And here you need D reference, I think.
Okay.
Oh, function parameter shadow. I don't know. Call this G for now. Try.
That works.
Are we
So-
using the add function? Yeah, we are. Cool.
Yeah, we are.
Great. Great. Now you notice that this kind of suck. You have to create a separate function. Now, I'm not
Yeah.
sure if Zig have added lambdas or would add lambdas, official support for it. But there is a trick which you could do. You could create a struct, an anonymous struct, right? Create your function there. You see where I'm going with this? Kind of suck, but well, that's an option. And so you create an anonymous struct, you create your function there, and you take the end.
Okay. Yeah.
You see?
That's.
Try if that
doesn't
even
look
works.
Yeah.
Yeah, I don't know why they didn't add closures, man. That suck. Unless if they have added it, I don't know. There
Okay,
you go.
it works.
It works. But yeah, I think Zig developers would just do it, just copy paste as you were doing before, really. But that's there, right? But honestly, I would, instead of this mess, but you could leave this element wise for, you know, for the user.
Yeah.
If you want that. Other than that, I would just go on and use the other way that you were doing before, just copy pasting stuff.
I just run the mul there and that works as well.
Yeah. Us Zig people aren't fancy enough for lambdas. We're simple country folk. But how would you do such a thing? Like, you have an element-wise function, and you want to run a function on it. Like, how would you do this in Zig? Or you don't do it? I don't know.
Yeah. I don't know.
But yeah, I think Zig devs would rather just do it the way that you've done before, at least for this one. So, what it was, I've never do that in Zig. Where is that thing? Where's the element-wise function? Okay, there you go. So we just say, oops, what I've done. Oh crap, okay. So this, and let's just say LHS times, oh well, plus equal RHS. Is in it, invalid, oops. Just like that. Would use the for loop instead. But we could leave that for the user element-wise.
Okay.
Though, I kind of, that's what I don't like about runtime asserts, is that you have to do it for every function.
Yeah.
So anyways, though, like in Rust, we would actually do the same thing, but we would also have like fn mul in safe, right? And basically you have to guarantee that it is the same shape, so we don't have to test every time. So like it would have basically something like this, right? So I would just, let's say, copy this, right? And it would have mul and safe. I mean, in Rust, we actually have an unsafe keyword, right? So you can only do this in an unsafe block, meaning that you know exactly what you're doing. And then we would have something like, we don't need this, and we would just say mul and safe here. You see?
Yeah.
And then in Rust, you would document the unsafety. Self. You see?
Yeah.
I don't know if Zig people does this too, but that's how you would kind of do it in Rust. So yeah, assert same shape. But honestly, for now, let's just keep it simple, I think. Anyways, so what's next? What you need next?
We need to do negate now. So
the other version that you could also do with this is just don't do it and let the programmer mind his business.
Let him worry about it.
So yeah, go
on. So I'll make a nag one.
Okay.
I feel like that's
all right, what's next now? Do you need anything else?
I'll just check this now. Just test this.
Okay. Oh, never mind. This is a unary function. Type comtime int here. Can I actually do something like this? I don't know how we would do in Zig. Well, yeah, there is a way. You could say as. You see what I'm doing?
Yeah.
Well, as scalar, I think. But I would honestly, now you're gonna need to make sure that -1 is convertible to scalar. I would honestly, what I would do in this case, I would just say equal to minus val, I think.
Minus val. Yeah, that's fair. Okay.
Okay. Negation of type F64. Yeah, we need to dereference this. Okay. Cannot assign to constant. What's the problem there? You missed something? Yeah.
I'm not sure. Is it like
Exactly.
do I have to dereference this as well?
Yeah, dereference it. There you go.
Okay, there we go.
Okay.
Very cool. We need to let me just see. We need to do.
Do you need the inverse too?
No, we don't need inverse.
Okay.
Because you just multiply by like a fraction.
Alright, so what's the next step now?
We need to do what's called a sum reduce. So like adding everything in the tensor together.
I see. So sum, right? So call it sum.
But like it's kind of weird because you do it like if you look up the NumPy one dot sum, it's like you add along an axis.
Oh, I
and
see.
It's kind of weird.
You could. Do you need the per axis one, or can't you just sum the whole thing? No.
Well, like sometimes you want to like add
Just
just
sum
like
only one
each
axis,
matrix.
right?
Yeah.
Interesting.
Once we have this, if we have this, then we can implement like a basic
But yeah, maybe
neural
start
network.
implementing that thing that you want to implement first, and then when or do you need it from the start?
Which one? What one are you talking about?
Like, can't you start already until we reach this point? Maybe, so we can start using the tensor a bit.
Yeah, we can do that.
Okay.
We do have a good bit of like this is gonna take us a while
All
to
right.
even get something built.
Cool. So maybe let's
So
try something more interesting for now.
we could start building the graph. This is gonna take a while, man. Let me think. If you look at the original one, we have because you have to build up this. You have to build up this sort of, you've seen neural networks. They look like this graph of you know how neural networks work, right? Like they have
I know only the basics. You would like have a tensor for what is it called?
like each layer, you know.
Wait, before the layer even. Let's start very simple. I remember there's inputs, right? You would have a tensor for inputs, and then tensor for weights, right? And a tensor for bias, yeah. Or it's not. Is it a tensor or just one value? I think it's one value bias.
Yeah.
So we would have. Okay, let's remove this stuff. So what is it called? Okay, tensor. Let me. Yeah, for sure. 64. The dimension of the tensor. I don't know. Let's start simple.
Yeah.
Dot init allocator. The shape would be. This way. Let's just say an arbitrary value. I don't know. And then you would have weights.
Yeah.
And then you would have a bias, which I think is one value, right? In this case, at least.
In this case, yeah.
Simple case. And then, how do you calculate the output?
Well, we should make the bias a tensor.
Oh,
you know?
I think in this simple case, it's probably just one value. No?
Yeah, but it would be a tensor. It would be like a 1-by-1 tensor. So because that's what you use to add. That's why we have the add function. So you multiply the input by weights.
Yeah.
And then you'd add the bias. Because you
So,
know the way we have to do a dot product. Do you know?
yeah, I know of dot products. Okay.
So we would have to multiply input by weights.
Oops, what I've done.
And then do a sum reduce, which would give the 1-by-1 tensor. And then we would add the bias to that 1-by-1 tensor. Do you know what I mean?
But either way, what tensor we should have here, in your opinion? Just it, like this?
It'll just be one. Just be one bias.
Okay.
So we multiply these two together. We have to then implement the sum reduce function.
So we have to say inputs dot mul, right?
We have to make a copy as well.
We need to keep out the inputs, the original inputs?
We don't have to keep it right now, but we will have to later on. But yeah, you can just...
Yeah, but we don't need it right now.
Yeah.
Inputs multiply weights.
Yeah.
Network
So that works.
Code
but now we have to do something like...
Actually, this is in place, so...
Yeah.
In fact, what we should do here... Hold on. Well, here's the case, actually, how we have structured it here. Well, first of all, let me not forget this. We're handling our own garbage. And the next thing is, I guess I would create an output tensor. So, okay. Actually, well, I could, so it should be the same type as inputs, right? The output, isn't it? Is that correct?
Yeah.
So we could say type of inputs, maybe. Dot.
Okay.
Well, dot copy. Well, hold on, what I'm saying. No. My bad. Copy. Yeah, we could just take a copy, actually, right? And use local for allocator. Is it?
And you have to defer that, don't you?
Outputs, I think, and then you would defer outputs.dnit. And what else?
We now multiply outputs.
So we copy it, and now we say outputs.multiply by weights, yeah. And what we should do next? Oopsies. Let's actually make this with this guy. All right.
So now we need to do like outputs.sum like that. So that'll like add them all together to make a 1x1 tensor.
Yeah.
And then we add that to we add the bias to that, and then you just have the 1x1 tensor.
Okay.
Do you know what I mean?
So.
Because that's the dot product.
Can't we just return one value for now? Like we would just say if and sum.
Yeah.
Self scalar for now. But I see why you would want to return a tensor, because later on we're gonna have more dimensions, right? So you would process multiple inputs and weights, right? At the same time. But yeah. Okay, so we would just to simply say var sum is equal to 0, right? And this would be u size. And then we would just go through the whole buffer, and we would say sum plus equal value, right?
Yeah. And then return sum. Yeah.
Well, I hate this. Okay, and now what we do, outputs dot multiply weights, and what we are gonna get right now? Const what? What is the result of this?
It's just outputs dot sum, or yeah, outputs dot sum
plus bias.
Plus bias.
I think bias for now could be just a regular value. I think.
Yeah.
So we don't need this.
And yeah, that's it. That's like the dot product, and then the bias added to it.
The dot product of what?
So that's what we've done, is we've done the dot product of inputs.
Oh yeah, so we could
weights.
have a dot product function actually.
Yeah, we can like add them together now. So we could do Yeah.
Other self scalar. And then you would say self dot multiply. Well, interesting. So self dot multiply by other, and then we would sum and return that. But then this would actually change the current value. But yeah, we're gonna basically have semantics of mutating. If you want to keep the value, just copy it yourself. So
Yeah.
okay, so instead of this, I guess you just say outputs dot dodge. Oh, what I'm saying? No. What I'm doing here? Well, actually,
yeah. Outputs are dot wait, I think.
Yeah. Dot waits.
And then you don't need to do. It's just.
Oh yeah.
Well.
Okay.
But see, and then
that would actually give you the that would give you the sum. So yeah, we would just do this, right? We would just say, hold on, just say directly.
Yeah.
That's what I remember. Why is the other self? It's basically the type. It would, in this case, it would be tensor f64.1, right? It's just the current type, that's self. So self is equal to this. So this struct, because it's anonymous.
Yeah.
So
result.
Oh yeah, copy could fail because it allocates. Same thing with the other ones, I think. Yeah. Hold on. Try. And try now. Named sum in void. Where's self.mul? Oh. I see. So return self.sum and do that. Okay, what about now? Yeah, it's kind of trippy that it doesn't return a new tensor, but that is the most efficient way. Compatible types U size and F64. What do you mean? Oh, yeah, I see. Well, scalar there.
Yes, pun scalar. Didn't we convert val? Or no, that's fine. Yeah.
Try again.
I'm not sure if that's right.
Good question. We could maybe do in Python and test it out.
Yeah. But we didn't actually.
But hold on, we didn't fill it.
we didn't set
anything. Yeah. So how we should allocate? Like, what should we feed it with? Maybe we should create a parser right now for CSV. Just joking. So, all right, but this is basically it. I think you're just supposed to fill it with stuff. Yeah. There you go. So we
Okay,
could
we
try
do
in
this in Python.
Python and see.
Yeah.
So, okay, I guess let's use the AI. It's the best at Python, I guess. So tensor of 100 elements, isn't it, right? Yeah. Create two tensors of 100 elements. Create 2.1D tensors. Oh, it's used random.
They're random.
We could use random, but no, we don't want that.
I think
We want to test it
it's just,
with 0. Well, full. Yeah. Oh, full like.
I think this is the right one.
You know, Python really trips me because you don't see any types or anything.
I know.
Everything is at runtime.
So a dot a. I think we can do that.
I don't know. Yeah, operator overload is weird in NumPy.
I think this is a matmul dot product. I think.
I don't know.
Plus 10.
So that's basically the inputs, right? So why full like?
I don't know. I just remember that being the thing. I don't actually know what the difference are.
Doesn't even go. Oh, there you go. Return a full array of the same shape and type as a given array. Oh. Shape and data type.
Oh, crap.
I think you probably want full here.
Okay.
Return a new array of a given shape. Yeah, and I'm not sure, but I think the shape is supposed to be like this. And then you would probably say here full like inputs. And then the fill value.
Yeah.
That's what it seems like it is. What we filled that, hold on, what did we fill that with? So the first one I filled that with 2 and the second 3, right? So does this, yeah, 2 and here 3, yeah? And the bias, what it was, 10. Okay, and what our own things did?
Is that the right size though? Is there not supposed to be like 100 of them?
What do you mean? Yeah, exactly. I just saved it, try again. And what Zig told us, which is correct, if you do D here, I'll try now. Yeah, there you go.
Oh, there we go.
The exact same thing, that's
We got
cool.
Awesome.
Full like, to basically create the same shape as input, so you don't have to tell it the shape again. So yeah. I mean, we could do a similar interface to NumPy actually.
Yeah, you could.
Like, how would you do full? So let's say, I guess, fill. Well, full. So you basically, oh, AI already doing stuff up. Let's see if it figured it out. So you get set allocator, the shape. I would honestly, I'm not sure if there's consensus on this, but I would put maybe the allocator at the end. And then there's shape and the value, fill value. So error defer t.d init, t.fill value, and return the t. You see?
Yeah.
And now, instead of doing that weird thing, I guess we could just use .full. Which, like this, right? I don't know, I'll just create an alias for tensor. What should we call it? T maybe? And same thing.
What's the difference between doing type and const for the types?
Oh, sorry. That's how you do in C++. You say type.
Oh, okay. Okay.
Okay. Full like. Let's see the AI. Great. But hold on. Full. Yeah. Self.shape. The value. And self.allocator. Oh my god. Let's go. So here you would say you don't need this anymore, and you would just say full like. Oh crap, no. You would say inputs try inputs dot full like and 2. You see. Maybe you still want the allocator though. I don't know. Okay. Full like, and there you go. What else? So after that, we just say dot product plus bias.
Yeah.
Which is what we're doing, right? So yeah, does this work? Oh. Oh, it should be var. And let's give, what is the values that we used again? 2 and 3. There you go. Great. Is there a name for a dot product plus a bias?
Oh,
Like a dot and
it's like
plus.
linear. It's like linear or something. I don't know.
Oh.
I think there's a name. Like,
hold on, let me ask
linear.
let me ask the AI. Is there a name for
I think it's like a linear layer
operation?
or something. Because it's like a linear function, you know?
Yeah, it's basically a line. Actually, it have another name even, not just a linear. Yeah, it does have another name because you have plus. It's commonly referred to as translate what? Affine transformation, I think.
Yeah.
Or linear.
So, yeah, I think.
Affine. It's a linear mapping method that preserves full and straight lines and planes. Not really. There's another, but anyways, so that's basically it. That's cool. So yeah, is there anything?
We could implement
yeah,
like just one more thing. If you want.
what is it?
It's the activation function.
Oh yeah. So how are we gonna do that?
So we can implement ReLU, which is literally just like max of the input or 0. Do you know what I mean?
Oh, RLU, right?
ReLU, ReLU.
Oh, how do you spell it?
It's like ReLU.
So I think what we really want right now, what this is called, inputs plus weights and bias. I think it's called Neuron, maybe, isn't it? Or,
yeah. Do you see?
no, neural network, isn't it? Not neuron. Because I think every neuron have one input, right?
Yeah.
And one weight and one, well, yeah, one input and one weight, right?
One neuron would have like a bunch of inputs.
So
All
this
of
should
those
be a
multiplied
neuron
by
then?
weights. Yeah, would be like.
Okay, so just define for me a neuron. Struct. So what should we have here?
Well, a neuron would just be like a tensor, just a one-dimensional tensor, like basically T. And then you'd have like a bunch of neurons would be.
But like, where is the inputs and the weights here?
Yeah. Well, you could have
The perceptron.
you'd have inputs of
Okay.
type T, weights of type T, and biases of type T here. What's T? It would be of type T as well, except it would just be the scalar really, but same thing.
There's not
But
a single. Okay.
but we don't really need to implement a neuron at all, like it in code
Yeah, it
anyways.
would just be a neural network. Okay.
All we have to do is like link up the tensors.
Actually,
And
there's a
then
way to do that. So like you would have a neuron, right? But you would make a multi-array list. So there's an interesting standard library collection in Zig called multi-array list, which allows you to make use of data-oriented. So like you would have a neuron like this, and then neurons, or I don't know what to call it, but layer, right?
yeah.
It would be, I guess, a cd.multi-array list neuron. I'm not sure. I have to check it out again because it's been a long time since. Structure for arrays. I'm not sure if that's really what I want, but so yeah, you have a monster struct. You create that, and then you append, and then you could go. I think that's probably it. So basically what Zig would do here, it would turn the struct into an array of inputs, an array of weights, and a bias. Though the problem with that is not exactly what we want. Because here we allocate our own memory in the tensor, so. But yeah, that's just something that is possible with crazy Zig. Anyways. So we would just have, I think, a neuron layer, or neural layer actually, neural layer, isn't it? And it would have a tensor. For now, let's just say scalar f64 and another, and the scalar would be just f64 in this case. Though you could also, well, anyways, this, right? Is that correct?
Well, no, because that'd just be one neuron. Like
oh,
because
my bad. Hold on. Where is the the shape? Never mind. I see. So this is the
it depends on how many.
how
It depends
much
on how many
neurons? Yeah.
neurons you.
So we gotta make a function. But actually, hold on a second. What? Bro, I'm confused. Well, no, that's the dimensions, bro. That's just the dimensions, so it would be 1D tensor. The actual size is at runtime. You see? So this is right?
Oh, dimensions. So that. Oh yeah, it's a one-dimensional one. Oh yeah, okay. Well, because if it's one-dimensional, it's only going to be for one neuron. Do you know what I mean? Because you're going to have, like, let's say you have a tensor of 100 inputs and a tensor of 100 weights. They're all going to go into one neuron. They're all going to be dot product
So
together
this
into
should be a
one
neuron then.
Yeah.
Okay. So how do we create the init function? There you go. And there's a for, so the AI already said forward function. F64 self.inputs.dot product self.weights plus self.bias. Right? And for the activation layer, what we're gonna call that function in the neuron?
Just the Rayleigh. Or just implement Rayleigh.
Like, but what's, isn't it called maybe something activator ID? I don't know. Yeah,
just call it
something like this. All right, RLU self.forward. Is that correct? Yeah. Okay.
Yes, that's right. So you just have to implement Rayleigh.
So really, what is it? Max x0. So yeah, implement it. So RLU. Well, the AI already did.
Of course.
But hold on, is that really correct? If x is greater than 0? But can't you just say max? Yeah, could just say this.
Okay.
The activation function could also be, but what the forward F64? So it could be an oh, what? Oh, Fn. And what does that return? F64? Or is it, yeah? And so how are we gonna do this now? So okay, var neurons, neural layer. What? No, never mind. Remove that. Neuron. We need the init function, yeah?
Yeah.
Where's that thing? Hold on. Okay. Here we're just taking the inputs and the weights, and finally the bias, and then the init. So defer neurons.deinit, or neuron.deinit. Okay, and what's we gonna do? Const activated, neuron.activate early, and then just that.
Yeah.
Aren't we actually doing that? Hold on, forward. So I don't think we want this stuff right anymore. How it's doing the outputs. So basically we don't need these. And we actually don't want these either. So it's just a matter of saying, well, because, you know, the neuron would take care of the allocating them, I think. Pretty much, yeah. Local variable is never mutated. Like this. Expected error union type found. What? Oh, I see. We don't need the try then. But then how did the init? Oh, I see. I see. So neuron activate. Cast the scars, const qualifier, dot product. So here we need self to be mutable. Probably same here. And probably need more of that. Seatbelt run. Expected type main.tensor found const. Oh, yeah? Activated 600. What? Yeah, is that true? Is that correct?
Yeah, that's right. Yeah.
Okay, cool.
Yeah, it should be the same as the,
So
like if you made it a negative number, then it would be
negative?
0.
Okay. So yeah, I think we have done it.
Yeah, we created a forward pass of that now. We can't train it, but
Yeah.
it works.
As a start.
Yeah.
So yeah, pretty cool stuff. Could just use tensor t here, t here. And yeah, pretty much, pretty cool.
Yeah, it was pretty cool.
Is there anything? So, is there any questions, by the way? I'm just gonna put this into its own into its own file right now. So I can just create a new file called tensor.zig. Put it here. We may need public there, though we also need a cd here. You can see the other file, right?
Yeah, I can.
Cool. And we could just basically const tensor is equal to import tensor.tensor. You see?
Yeah.
And there you go. And we could also put Neuron there too. Like const Neuron. New file, neuron.zig. Would put that there, and we need to import the tensor again here. There you go. And we need the t here, or we could too simply say tensor.t. Is that maybe public const t? So we don't even need the tensor anymore. Well, what I'm doing actually, neuron. You see what I'm doing, right?
Yeah, I can, yeah.
Okay. So t.full. And the neuron basically managed the initialization after that. So it basically takes ownership of the memory.
Yeah.
And pretty much, there you go. What do you think about Zig?
Sorry?
No module named neuron available within module roach. .zig. .zig here. Anything else? Let's see. It's not marked public, yeah. So put const neuron. There's no member named T. Whoops, I see. So const neuron is honestly not interesting. Oh, let's just remove that t then. Well, let's not make it public, right? Anyways, and let's just go with const. Actually, well, the question, can we actually say the full like this directly without? I don't think that works. But yeah. Anyways, let's grab the tensor here too. And finally the const t. And come on, run. Oh my god. Tensor is not marked as public. Public. Anything else? Full is not marked public. Public here too. Full is not. Oh, what? And it is not marked public. That sucks. The LSP just doesn't help. I mean, if it was a good LSP, it would actually show me the error without even having to compile, you know?
Yeah.
Let's see.
Are they working on that? Like,
I honestly
that's
have
like a
no
pretty...
clue. But like the Zig team itself doesn't work on the LSP. They just don't want to do that. At least for now.
That's kind of terrible.
So another team is working on it. Just open source. That is not marked pub. At least that's what I know.
I feel like if you want users to, you know,
Yeah, exactly.
use your programming language, like, you want good tooling.
Yep.
I feel like that's why
That's
people
why
like
that's why I actually don't use Zig that much. I use Rust, because the tooling
Yeah.
just sucks right now. Activate. Okay, good. So right now at least it works. And yeah, that was it. And real quick, I think I'm gonna give you one other thing, which is the arena allocator. You asked about that. Let's just do it real quick. No. Disable completions. Okay. So arena allocator, and you give it some allocator. And I'm not sure if you give it the allocator like this. Dot. So let's just call it arena actually. Let's see if this works first of all. And use local constants. Come on. Type is not a function. I guess I gotta instantiate that or what? I don't think. Oh no. What? Oh, init, my bad. And then I give it gpa.allocator. And then I guess I could basically say that allocator right now is actually arena, the allocator. Let's see if this works. Arena. Oh yeah. Oh yeah, so defer arena.dinit. Okay. Arena.dinit. So that works. So the nice thing about arena allocator, you see?
Yeah.
Is that you don't have to dinit anything individually. You just keep on initializing stuff. And when you're done, when you deallocate the arena, everything that is allocated using the arena gets deallocated.
Oh, okay.
So
Very
no
cool.
defer and stuff like that. The only
Yeah,
downside
that's
to
way easy.
this
Yeah.
is that you're not supposed to really go ahead and de-init one by one. So after using the arena, you should basically just keep on allocating, just like the stack, you know.
Yeah. Yeah, very cool.
So right now I don't need to de-init anything anymore. I just go directly right in. There you go. So I removed that de-init allocator, but it's a good practice anyway to de-init, but well, that's an option, right? So that's one allocator. So, but of course it takes an existing allocator, so GBA in this case, right? And then wraps that, gives you another allocator. So, you see what I mean?
Yeah. Yeah.
Yeah, I guess that was it for this stream.
All right. Yeah. I'm wrecked. I'm tired now.
That was a lot of cool stuff.
Yeah. It's a cool language, I think. I like the way you can just choose your memory allocators like that.
Yeah.
Yeah. Pretty cool.
So is there any last words?
No, I think that's all. That's it.
Yeah.
Yeah, thanks for doing this. This is pretty cool.
Yeah, that was very fun. Thank you too for coming in.
All right.
Okay,
I'll see you soon.
guys. See ya, everyone. Thank you all for coming in. Thanks for the Vrisco, Andrew Fury, Robert, Wanda WS, Hats, Selim, Jonathan Marler, Tunify Basic, Aldrich Benalan, and CodeMoon. Thank you all for coming and tuning in, and see you guys later. Goodbye.
All right.